And so we've already done a few of these. So once again, the equilateral triangle we've done. What's the measure of, or again here, if the n, the number of sides is 3, each interior angle is going to equal what? We know that it's 60 degrees, right? And we found that by taking the sum of the total sum of the angles, 180, dividing by the number of angles there are, 3, and that gives us our value, 60. Okay. For a square, again, we've already dealt with this. If the number of sides is 4, we already know each interior angle of a square is going to be what? 90 degrees. And the calculation for that is, again, take the total sum of the angles in a square. What's the total sum? 360, divide by the number of sides, and that gives you your measure for each interior angle. And so find just on your own, what would be the measure of each interior angle of a regular pentagon? So calculate that just really quickly on your own. And so if you knew what the total sum of the angles were, which is what? Total sum of the angles in a pentagon, any pentagon, whether it's regular or not, is 540. Divide by the number of sides or angles that you have, 5. 5 goes into this 5 one time with nothing remaining. 5 goes into 4 no times with 4 remaining. 5 goes into 40 8 times. And so you get your answer, 108. So really what we did right here is we took, in just generic terms, we took our n-gon, n number of sides, and we used the calculation that each interior angle is equal to the sum of the angles, which we saw yesterday, the last class, as n minus 1, or n minus 2 times 180, and then we divide by the number of sides or number of angles, and we get our answer. All right, so if we begin with an equilateral triangle where n is equal to 3, and we want to find what each exterior angle is equal to, well, if we know that each interior angle was 60, what does that mean each exterior angle has to be? Its linear pair, or its supplement, 120. So you can think of this in a couple different ways. So what you could do is you could use the relationship that an exterior angle and an interior angle are just linear pair. So they're going to be supplementary to each other. So if you know what the interior angle is, its supplement will be the exterior angle. Vice versa, it works the other way as well. And for a square, so in a regular polygon where the number of sides is 4, what does each exterior angle have to be? Again, if we know each interior angle is 90, its supplement will be 90. So we can use those relationships to find each exterior angle. We can also use a calculation, the same type of calculation that we use for each interior angle. Take the sum of the exteriors, divide by the number of them that appear. Well, what's the sum of the exterior angles for all polygons? So it makes a nice easy equation, right? 360 divided by 3 is going to give you 120. 360 divided by n, 4, is going to give you 90. Okay, so what would be the measure of each exterior angle in a regular pentagon? So you could take the measure that we got on the last problem, which was the 108, right? And so we could find its supplement. Well, the supplement of 108 is 72, or we can use the equation, the sum of the exterior angles, 360, divided by the total number of sides, 5. 5 goes into 36 7 times with 1 remaining. 5 goes into 10 twice, giving you 72. Okay, so once again, we have just a generic form for this. If you're dealing with an n-sided polygon, regular polygon, and you want to calculate each exterior angle, it's simply going to be 360 divided by n. Okay, what's the measure of each exterior angle of a regular decagon? Again, if you take each exterior angle is equal to 360 over n, you wouldn't have to go through this problem because you can do it mental calculation. Factors of 10 cancel, leaving just 36. Now, what relationship does this have with sample problem 3? Each interior angle for the same polygon? They're supplements. And it should be because they are a linear pair. Right. Now, if we took this equation here and we needed to solve for n, so if we knew what the exterior angle was, but we wanted to solve for n, we could take this, let's say each exterior angle represents x. So x is equal to 360 over n. If we multiply both sides by n to get rid of our fraction, and then we isolated n by dividing by x, you see that the same calculation, 360 over the measure of each exterior angle, is going to allow you to find what n is, the number of sides.